Last stretch here. We're doing Le Chatelier's principle, and now we're going to focus on temperature. And when we're done with that, we'll focus on the stress of pressure. Okay, when they tell you about the temperature and how its effect on a reaction, they have to also tell you if the reaction is exothermic or endothermic, because if the reaction is exothermic, you put heat as a product. If the reaction is endothermic, you put heat as a reactant. So in our Haber process, the one that we worked with before, this is an exothermic reaction, meaning that heat is considered a product. Heat is released when ammonia is produced. Okay, so what happens if you increase the temperature? So if you increase the temperature, that's the same as saying you're increasing heat, okay? If you're increasing heat and heat is a product, what do you think is going to happen? Again, the equilibrium tries to shift to reduce that stress. So if you're putting in more product, it's going to shift towards the reactant side. So if you increase the temperature, meaning increase the heat in an exothermic reaction, it's going to shift to the left and make more reactants. Okay, well, what if you get your bonus based on how much ammonia you produce? So if you try to run this at a high temperature, you're not going to be getting a lot of ammonia. All the ammonia you're making is shifting back to the reactant side. So the best way to run this reaction is to cool it down, meaning take away heat. If every time you run this, you run it at a cool temperature, you're taking heat away. If you take heat away, it's like removing some of the product. If you remove the product, remember what we said earlier, if you remove some of the product, the equilibrium is going to shift to try to make more product. So this reaction, if you want more ammonia, you're going to have to reduce the temperature, which means reducing the heat, and it's going to end up shifting to the right to make more product. Okay, so when we're dealing with an exothermic reaction, if you run it at a high temperature, it's going to shift everything to the reactant side. If you run it at a low temperature, meaning every time heat is produced, remove the heat by running it at a low temperature, it's going to shift it towards the product side. If, on the other hand, you have an endothermic reaction, so just this hypothetical here, let's say you have a hypothetical A plus B plus heat will give you AB, and they're all gases. So this is endothermic. If you increase the temperature, now this is endothermic, it's the same as saying you're increasing heat. In an endothermic reaction, if you're increasing the temperature, it's like you're adding in more of this reactant, it's going to shift to the right to form more products. To form more products. Okay, so in an endothermic reaction, it's a good thing to run it at a high temperature if the goal is to make more product. Okay, it shifts the equilibrium to get more product. If, on the other hand, you reduce the temperature, it's the same as taking away heat. You're like removing this reactant, removing this. If you do that, it's going to force the equilibrium to make more reactants. It ends up shifting to the left to form more reactants. So basically, your products will decompose to make more reactants. All right, So that's the difference between endothermic and exothermic reactions and how they relate to Le Chatelier's principle. All right, so understand that. If they ever ask you a question on a quiz or a test, or if I ever ask you a question, quiz or test, dealing with temperature, I'll give you the equation and I'll tell you if the reaction is endothermic or exothermic. Based on the location of where heat is, and you'll understand the shift. So if it's exothermic and you're increasing the temperature, shifts it over this way. If it's endothermic and you're increasing the temperature, shifts it over this way. Okay, the last thing is pressure. So let's talk about pressure as a stress. Okay, remembering Boyle's law. If you have high pressure, you have low volume. Okay? If you run a system, if you run a reaction at high pressure, it's going to shift to the side that has fewer gas moles. Oops, let me write properly. Gas moles. Why is it going to shift to the side that has fewer gas moles? Because now we have less volume. All right? High pressure means less volume. High pressure, less volume. Less volume, you want to go to the side that has less gas moles. So, how do we know how many gas moles there are? You look at the coefficients. This is 1 and this is 3. So this side has 4 gas moles. 1 plus 3. This side has 2 gas moles. So in this scenario, if you're running it at high pressure, meaning low volume, you shift to the side that has fewer gas moles, which is 2 is less than 4. So in this situation, it's going to shift to the right. Okay? Now, if you have low pressure, that means you have a bigger volume. Again, Boyle's law. Bigger volume means you can have more gas moles. So if you run it at lower pressure, it means you have more volume. It's going to shift